All right, welcome everybody. Welcome to Defensible Development with Secure HTTP Headers. How you guys doing? All right, right on. This is my second time at Devoxx, second time in Antwerp. I hope you guys are having as much fun as I am. My name is Frank Kim. I'm a consultant. I also do a bunch of work with the SANS Institute. Now, just curious, show of hands, who has heard of the SANS Institute before? All right, not bad, maybe 10% or so. SANS Institute's a computer security training company. They do all kinds of different security training. I'm specifically involved in the application security side. Before we move on, I want to give a quick shout out to my buddy, Jason Lamb. He actually travels a lot for work, so wherever he is in the world right now, thanks a lot, Jason, for helping to put together these slides. So let's go ahead and get right into it. We're actually going to be talking about 4 different things today. We're going to start off by talking about 3 different common web application security vulnerabilities and talk about how we can easily prevent them using, not by modifying the code, but by using different HTTP headers to mitigate these vulnerabilities from actually occurring. Right? The problem is that we as developers, we don't always have as much time as we might want to take to worry about security issues, right? Do you guys have all the time in the world to worry about security in your applications? No, yeah, nobody does. And so we're going to see how we can really easily build on the best practices that we already know about, input validation, output encoding, but also go ahead and utilize some of these HTTP headers that we're going to be talking about. Now, quick review real quick about cross-site scripting. This is just one quick review, one slide to set up the discussion here. Quick show of hands, who has heard of cross-site scripting before? Of course, yeah, it's pretty much everybody. Who's actually fixed cross-site scripting in their applications? Good. Looks like maybe half, a little more than half of the folks. Excellent. Excellent. So as you guys know, cross-site scripting occurs when some evil data, some bad data, is sent down to your application all the way down to the browser. And the browser renders this evil data. That's it. The evil data is usually in the form of JavaScript that is then executed on the client side to do some bad stuff. Right? Now, there's 3 main types of cross-site scripting, as you probably know. Let's start off talking about reflected cross-site scripting, where you might have a URL parameter with some bad data in it. The user clicks on a link, that URL parameter gets sent up to the app server, to the server, echoed back down to the browser, and executed. Right? Make sense? All right, I don't know if that makes sense for everybody, so let's switch gears for a second and talk about tennis. Any tennis fans out there? I think I see maybe 6 hands, which is more than usual. What about Maria Sharapova fans? Any Maria Sharapova fans? All right, a few more hands. Now, this is related to cross-site scripting because a while back it was announced that Maria Sharapova was going to be leaving the world of tennis. Now, I love telling this story. Who's heard this story before? She was going to be leaving the world of tennis to become a CCIE, a Cisco Certified Internetworking Expert. That's pretty hot, right? And it had to be true because it was jointly announced on both mariasharapova.com and cisco.com on the exact same day. Well, it turns out that it was actually some Russian hackers had discovered reflected cross-site scripting vulnerabilities in both mariasharapova.com and cisco.com, saved them up until April 1st, April Fool's Day, and published these links out on the internet. So when users clicked these links, they had a bunch of extra URL parameters at the end, exploiting the cross-site scripting vulnerability. The JavaScript code, XSS code, gets sent up to the server, echoed back down to the browser. JavaScript has access to the DOM, everything in your browser. So the attacker simply used it to rewrite the contents of the page on cisco.com and mariasharapova.com, issuing a fake press release on both of those sites. Right? Thereby telling the world, announcing that Maria Sharapova was going to become a CCIE. That is your classic case of reflected cross-site scripting. Evil JavaScript getting executed in the browser. Make sense? All right. Stored cross-site scripting is the exact same thing in concept, except instead of data coming from a URL parameter, the data is saved inadvertently, probably in your database or something, and then later sent back down to the browser itself. Reflected DOM-based cross-site scripting. Again, same concept, evil data getting rendered by the browser, but right, in this case, you might get the evil JavaScript from something like document.location or document.url. So let's see a quick demo. I'm going to switch over to the VM that I have over here. And this is just a page of links that I'm going to be using to navigate throughout the course of the talk. The first one here, right, we've got a very simple page. Make this a little bit bigger for you guys. And you can see from the URL bar, it's just a simple JSP, takes a couple of parameters. The message, which is the string hello, and the name. And we can go ahead and change this to anything that we want, and you can see that that data gets echoed back. Right, very simple, right? And this is a page that it looks like the UI, the feel of it, it looks like I designed it way back in 1997, so don't hold that against me. If we look in Eclipse here, right, we can see that the JSP is right here. On line 14, again, we're just using JSP syntax, echo these parameters directly to the output stream. That's it. And so, of course, an attacker is not simply going to go ahead and change these parameters to something else, but they might go ahead and use the standard script alert script. And you can see the data, the script alert script gets sent up to the server, echoed back down to the browser, and in this particular case, the JavaScript gets executed on the client side, because we've told it to go ahead and pop up an alert box. Who's actually tested their applications looking for cross-site scripting using script alert script or something similar? Good, maybe 40% of the folks? Excellent. And of course, an attacker is not simply going to do this. They might try to go ahead and do something like document.cookie, and you can see it pops up the JSession ID. And in this case, they wouldn't pop it up in an alert box, but they'd append it to a URL of a server that they control so that they can harvest the different active JSession IDs for users they might be targeting. So if I switch back to the slides here, so how do we prevent this from occurring? Right? Not by changing the code, not by doing output encoding or input validation, things that you still need to do, but how do we do this? How do we fix this, mitigate this? Using some headers and associated attributes. The first thing that you can do is go ahead and use the HttpOnly flag. Now, who has this turned on in their applications already for some of their cookies? All right, maybe 10% of the folks, not bad. Now, the HttpOnly flag, when you define the cookie as HTTP only, it ensures that the cookie will never be sent from the browser up to the server over a non-SSL connection. So that then an attacker cannot, oh no, excuse me, I'm mixing things up. The HTTP only flag specifically says that the browser, right, JavaScript, other client-side scripts, JavaScript running in your browser cannot access the contents of that cookie, right? Does that make sense? So this mitigates common cross-site scripting attacks, like attacks where hackers will try to steal your session ID using JavaScript, like we just saw with the alert pop-up box. So fortunately in Java, finally, in Servlet 3.0, which was, what was it, about a year and a half ago that it was finally finalized? In Servlet 3.0, we can now configure WebXML directly using some XML like this to specifically say that the JSession ID should have the HTTP-only flag appended to it, right? Thereby mitigating some common cross-site scripting vulnerabilities. Make sense? Down at the very bottom, you can see that if you also want to go ahead and set HTTP only on some cookies, unfortunately, there's not a .set HTTP only method on the cookie class itself. Instead, you have to manually create the cookie, like you see down at the bottom, to go ahead and append HTTP only at the very end and go ahead and manually add that cookie. But again, for the JSession ID in particular, you can go ahead and automatically set the HTTP only flag like this. Now, that's all well and good, but there's still a problem. Right? There's a couple issues that we have to think about. What if, right, when you type in mybank.com and you go to some website, right, you don't always manually type in https:// do you? Most users simply type the URL of the website that they're trying to visit. Well, at that particular point, on the back end, what do we usually do? We usually redirect the user, right, from the non-SSL connection to the SSL connection for a secure application. But that leaves a little window of opportunity open for an attacker to see the data transmitted in clear text when that redirect occurs, right? There's also another associated problem. Usually, a lot of websites that I see, a lot of applications that I see, is they'll go ahead and redirect you to SSL, but they will still have the SSL version that they redirect you to, but they'll still have the non-SSL version available after you get redirected. So if you're logged in, you can manually go ahead and change, right, HTTPS to HTTP. So there's an opportunity for an attacker to actually downgrade your SSL connection to just HTTP. And there's a security researcher by the name of Moxie Marlinspike. Anybody heard of Moxie? Yeah, a handful of people. He released a really cool tool called SSL Strip that does exactly this. Google for Moxie, Google for SSL Strip. It's a really cool tool. And it will go ahead and look at stuff on the wireless network and try to automatically downgrade your connection to your website, to your application, from HTTP to HTTP, HTTPS to HTTP, right? So that they can go ahead and see all the data that you might be transmitting. So how do we prevent this from occurring? Well, there's another header called the X-XSS-Protection header. I got a little bit ahead of myself, guys. You guys will have to excuse me. The XSS, this is a little bit different. I was going to talk about SSL Strip and that tool a little bit later on, but I skipped ahead a little bit myself. Are you guys confused? I think I confused myself as well. Right? So let's just pause and reboot for a second. We were talking about HTTP only, cross-site scripting, getting access to document.cookie and stealing your cookies, right? So that's only good for your cookies, mitigating one type of cross-site scripting attack. Well, what else can you do? Well, you can also use the X-XSS-Protection header, which is actually now enabled by default in all modern browsers, except for Firefox. And Firefox is actually working on this. If you actually look online, look at their bug tracking tool, and look up that bug ID, you'll actually see that it was just simply an oversight that they didn't include this yet. Now, it's enabled by default, and you can manually also enable or disable it using these various headers. So you can say X-XSS-Protection 1 to turn it on, which it is by default in the browsers, X-XSS-Protection 0 to turn it off, right? And then finally, you can add this mode equals block down at the very bottom. And in your Java code, right, it's very easy. All you have to do is add these headers. Now, of course, you probably wouldn't necessarily do this in your Java code. You might configure this in the web server itself, right? Anybody used these headers before? XSS protection headers? I think I see Mike sitting up there. Of course, Mike has used them. All right, so let's do a quick demo of the XSS protection header. Switching back to the VM over here. All right, so I'm going to go back to the home page here. The very first link that I clicked up here, right, where we saw the alert box containing the cookie, remember that? That was actually using Tomcat 6 under the covers. Now, it turns out that Tomcat 7, by default out of the box, now appends the HTTP only header to the JSession ID as well, thereby preventing client-side script, JavaScript, from accessing your cookie value, right? So this second link from the top is actually using now Tomcat 6. It looks exactly the same, under the covers, just running on a different server. And let me make sure that I do this in Chrome, actually, because Chrome is the browser that supports the XSS protection header. And so if I do script alert script here again, right, you can see that the alert box doesn't actually pop up. But if I view the source to this page, on line 10, you can see that the actual script alert script actually gets sent down. But the browser knows, right, that there's a reflected cross-site scripting attack potentially in play here. Right, so it goes ahead and prevents that script from getting executed. And if we try to do the exact same thing with document.cookie, what do you guys think is going to happen? Nothing, yeah. If I go ahead and hit enter now, right, nothing happens in this particular case because it is blocked by the XXS protection header. Now, what I wanted to show you in Firefox over here, if we do the exact same thing, and do script alert document.cookie, now what's going to happen? Because remember, Firefox is the browser that doesn't support the XSS protection header yet. But Tomcat, which we're using, right, Tomcat 7 in this particular case, has the HTTP only flag set for the JSession ID. So when we try to access the cookie from JavaScript, from the alert function, right, you can see that the alert function actually executes, but the JavaScript doesn't have access to it. Isn't that awesome? Right? So far we've talked about two things. Right? The HttpOnly flag that prevents JavaScript from getting access to your cookies, like we see here, and the X-XSS-Protection header, which is implemented by default in a number of browsers. Now, if I go back and look at that X-XSS-Protection header right here, and instead of using the default mode, I'm going to go ahead and set the mode to block here on line number 4. And now when I try to go ahead and access the same thing, access the same page, what's going to happen when I set it to mode equal block? When I hit enter, now the page doesn't render at all, right? Because the browser is saying that it receives this header, and the browser knows that it shouldn't display the page at all, versus displaying the page but not executing that part of the JavaScript. Make sense? All right. So if I switch back to the slides here, all right, again, that was 2 ways to prevent cross-site scripting. We're actually going to talk about 3 different ways. And the third way is using content security policy. Who's heard of content security policy before? That's pretty good. Maybe 20% of the folks. Out of the folks that raised their hand, who went to Mike West's talk earlier today? That's all the 20% of the people, I think. All right, Mike, are you in here? Raise your hand. We got Mike sitting right up in the middle here. Right? Mike actually works on content security policy. And content security policy helps to mitigate cross-site scripting, specifically reflected cross-site scripting, by letting you define a whitelist of origins, of sites, from which you are allowing, well, that's in this particular case, JavaScript to run from, JavaScript to be loaded from. Right? And because you're defining that whitelist, you're defining what websites that you trust, right, to load that script from. Originally developed by the folks over at Mozilla, currently a W3C draft. It's going to be finalized very soon. Okay. And it is supported in a number of forms in all the most popular browsers. Right? Firefox and IE 10 support it using the X content security policy header. Chrome and Safari support it using the experimental X WebKit CSP header. And talking to Mike earlier, right, Chrome already supports just using the content security policy without the X in front, which is going to be the official header name when the standard is finalized. Right, but right now we can use these in the various browsers. Now this is very good, right? I love CSP. It's one of the best ways to prevent cross-site scripting from occurring. But there's a little catch. When you go ahead and implement your app using CSP, you have to make sure that you don't have any inline scripts, any inline JavaScript. You know how you can just put script tags directly in your HTML, or you might have some JavaScript code in your event handlers? You can't do that anymore. And it's the exact same thing with CSS. Right? You have to make sure that you don't have that, because the browser can't differentiate between what is a valid inline script and what is potentially an evil inline script. Number of different CSP directives that are supported. The second from the top, you've got script source, right? How you prevent cross-site scripting from occurring, defining the list of sites from which your app, your website, can load JavaScript. Style source, same thing for styles, images, media, frames, fonts, and so on. Now the very first bullet, default source. That one specifically says, well, what's the default if you don't specify locations, origins for all of the other ones, right? Let's go ahead and look at a couple different examples. 2 on this slide. The first one is just an example saying, okay, let's specify the default source to be self, ensuring that any of those resources can only be loaded from your particular origin. And the second example is from Mike's site right here, right? From his particular website, you can see up at the very top the content security policy. This is from a month or 2 ago. Default source is none, so you're not trusting anything else. Style source coming from his CDN, his content delivery network. Framing, only from YouTube and SlideShare. And scripts, specifically, only from his CDN again, as well as from Google Analytics, right? Because he wants to see what's going on. Images from here, and fonts from this location down at the bottom, right? From his CDN as well. Does that make sense? Now, what if you have a bunch of inline scripts or inline styles, and you have an old legacy application. It's going to take a little bit of time to go and refactor that, right? Maybe you've got to go through QA and all that typical stuff. Content security policy also supports a report-only option. And you can see it's using at the top here the X content security policy report-only. And this is actually what Facebook had on their website not too long ago. Here, again, since it's report-only, you can see that they're allowing everything. But scripts are only allowed from these particular locations. And down at the very bottom, we've got this report URI attribute. And it's saying that, hey, if there's any violations or if anything happens with content security policy on the browser side, go ahead and send up to this URL, facebook.com csp.php, go ahead and send up some data in JSON format to describe what actually happened. And the second to last line here is interesting. They actually had this on Facebook. There's this options attribute where you can allow inline scripts and allow eval, which you don't want to do, because that still actually allows cross-site scripting to execute on your website. So I was very curious why they had that up there, actually. But let's go ahead and take a look, quick demo of content security policy. So I switch over to the VM again. Here, again, I'm going to use Firefox. And going back to the home page here, where I've got my list of links, the content security policy link. And if we try to do the exact same thing and say script alert, right, you can see in this particular case it doesn't actually execute. Now I also have another tool running here called Peros. It's a web application proxy. Anybody used web app proxies before? Quick show of hands. All right, that's good. Maybe 60, 70% of folks. For those of you that have not used it, a web app proxy basically sits between the browser and the server and allows you to see all of the communication going up from the browser to the server and back down. Right? It's running on your machine, access a proxy to the browser itself, letting you see the different headers, other fields that you might not be able to normally see in a regular browser itself, like normal users can. I'm using a proxy here just for demo purposes called Peros. There's lots of other great ones out there. OWASP, Open Web Application Security Project, has one called ZAP, Z-Attack Proxy. There's another one called Burp Suite, my personal favorite. But you can see here in Peros, on the left-hand side, you get the site tree, the hierarchy of all of the different things you visited in your browsing session. And down at the bottom, you can see all of the different requests that were sent from the browser to the server itself. So when I go ahead and click on one of these, you can see that the request and response tab gets highlighted here. In this case, this is the request that gets sent up. But the response that comes down, you can see right here, this is just an example showing the content security policy is actually being set on the server side and pushed down to the browser. In this case, all we said was default source equals self. And this simple header prevented that cross-site scripting from actually executing. Now that's pretty awesome, right? Defending your app with just a simple setting like this. Now, if I go over to Eclipse, and in this JSP, I'm going to go ahead and turn off, not turn off, I'm going to go ahead and change the CSP definition to say default sources against self, but adding these options where allowing inline script and allowing eval, right? Which we don't want to do that, but I'm just showing you that this is what happens when you actually have this configured. Now, when we go ahead and hit enter, we see the cross-site scripting, the evil code actually executes successfully. Right? Bad. That's very bad. So if I switch back to the slides, any questions on cross-site scripting? Cross-site scripting, 3 different ways that we can use things we can do to mitigate cross-site scripting. What was the first one? Using the HttpOnly Flag, preventing JavaScript from accessing the contents of your cookie. Second one was using the X-XSS-Protection header. Right? And finally, you could also use content security policy. All right. Any comments before we move on to the next thing? Yes?
I have a question about the XSS-Protection header. When you send this header, how does the browser know that an XSS is occurring? Like, you say, protect me from XSS, but how does the browser know, okay, there is an XSS right now?
So the question is, with the XSS-Protection header, how does the browser know that an attack is occurring in that particular case? And basically, yeah, the XSS-Protection header is really only defending you against reflected cross-site scripting. So it knows what stuff was sent up in the URL parameter, for example, and it sees that data coming back down. And so that's how it's able to compare and figure that out. Good. Anything else? Yes, in the middle.
Is there stuff that I can do with X-XSS-Protection that I cannot do with content security policy? Or?
Good question. Is there stuff that you cannot do with the XSS-Protection header that you can do with that you cannot do with the content security policy header that you can do with the XSS-Protection header? And the content security policy, the header, is much more robust, right? Well, it gives you, as you've seen, a lot more options to whitelist different sites. Now, they both protect against reflected cross-site scripting. But the catch with CSP is that you have to do a little bit more work, right? You have to potentially, if you have an old big application, make sure you don't have inline scripts, inline styles, and so on, right? So as a stepping stone to that, I mean, I would say everyone should get to content security policy. But you can also, well, by default, right, your users are protected using the XSS-Protection headers because it's supported in all of the most recent browsers, except for Firefox yet. Yes, right there.
Just going back to the earlier question, that detection, is it based on blacklisting? How is it being done?
Yes, so that's a good question. The comment is, well, the detection in the XSS-Protection header, how's it being done? And this is also related to the question about comparing that between content security policy, is that XSS-Protection header is really doing it based on a blacklist of, hey, we think that there's some bad data in this parameter that's being sent up. Whereas content security policy is using a whitelist, right? A whitelist of known good sites, or sites that you've defined to be trusted to load content from. So that's an excellent distinction. All right, so now let's move on to session hijacking. Now this is where I said stuff a little bit too early, right? So session hijacking occurs where, well, you guys know what this is, right? If you are sitting in a cafe, in a coffee shop on the wireless network, if the wireless network is not secured, you, as the victim in the top up here, might be trying to go to some sensitive site, like mybank.com. And, well, unbeknownst to you, there's actually some attacker, as represented by the red computer with the little black hat on it, that might be on that local wireless network as well. Well, what is this attacker going to do? If the connection is not encrypted, the attacker is going to go ahead and sniff that connection and potentially steal your JSession ID to conduct a session hijacking attack by stealing your session ID and replaying it to the server to log in as you, right? Which he does here in step number 3. So how do we prevent this from occurring? Right? Now this is again where I kind of mixed up the two. I always do this. I always mix up the names between HTTP-only and the secure flag. But the secure flag is the one that tells the browser to only ever send the cookie, contents of the cookie, up to the server over SSL, right? Thereby mitigating session hijacking attacks. Now that makes sense, right? Now in Java, fortunately, as of Servlet 3.0, you can also very easily configure your application to have the JSession ID, have the secure flag set on it as well, using this little XML snippet. And if you're manually creating some cookies, you can use the cookie class using the .setSecure method to set this to true, right, to enable the secure flag on all your cookies. But then this now gets into what I was mentioning really briefly ahead before, right? Moxie Marlinspike has a tool called SSL strip. What if an attacker is able to downgrade your HTTPS connection to HTTP? And there's also that small window of opportunity when you, in your application, might be redirecting the user from the non-secure to the SSL version, right? So in those particular cases, this is where we have the strict transport security policy header, strict transport security header. Now, who has heard of this header before? Quick show of hands. Now, keep your hands up. Who has heard of this header before the talk this morning? All right, so maybe a handful of folks. All right, so strict transport security policy specifically tells your browser to only ever talk to the server over HTTPS. Well, how does it do it? The very first time that your browser connects to some application, it's going to get sent down an SSL certificate. Right? If you have the strict transport security header set, it's going to inform the browser, tell the browser to cache that SSL certificate on the client side, on the browser. So the next time you go to that website, even if you type HTTP, the browser is still going to do an SSL connection with the server. Right? And the way that you configure it is using the header down at the bottom. Specifically, you say strict transport security. You can also include subdomains, but you define here the max age that the header is actually valid for to mitigate session hijacking attacks. Right? Implemented in Firefox and Chrome, currently in IETF draft. Right? Does that make sense? Any questions on this or any other thoughts pop into your head about something we've talked about already? Yes?
What's usually the max age? It's the same as the JSON ID's age, or?
The question is, what is usually the max age that you might want to set? Would it be the same as the JSession ID? Normally, the JSession ID is maybe, I don't know, 20 minutes, an hour or something. You would want to set this max age to something much longer, right? Maybe months, maybe a year, maybe years, right? To make sure that users, as they're using your app, will always be SSL under the covers. Yes?
You were saying that this is an IETF draft. Where did this previous headers W3C?
That is a good question. So this one is an IETF draft, whereas content security policy was a W3C draft. And I don't know, maybe afterwards Mike can comment a little bit on this, but yeah, they're just different bodies that came up with these particular drafts. I don't actually have all of the history with which bodies are submitting these proposals. All right, anything else before we move on here? All right, the last section here, we're going to talk about clickjacking. Now, who has heard of clickjacking before? All right, maybe 20% of the folks. So clickjacking actually occurs when I, as the attacker, trick you, the victim, into clicking a button. That's it. But the button that I'm tricking you into clicking is invisible. Right? So I'm tricking you to click some button, and you clicking that button usually has some nice side effect, some benefit for me as the attacker. And the way that this works, as you can see in the image here, is that the victim site is basically placed in an invisible iframe whose opacity is set to 0. And you can see the victim site, in this case it's Twitter, the victim site is in the foreground, right? But it's invisible. And in the background, you've got the attacker site. And in this particular case, the attacker site is enticing you to click this play button in the background, or what you think is the play button in the background, by saying, hey, go ahead and play this really fun game. But unbeknownst to you, you are actually clicking the Twitter button that I want you to click in the foreground. All right? Now, that's a lot of words talk to describe what clickjacking is. So let's go ahead and do a quick demo. So if I switch over back to the VM, go back to the home page here. Now, in the clickjacking section here, we've got a victim site. And as you can tell, I also coded this site in 1997. But it's simulating that you are agreeing to pay me some amount of money, right? Just basically simulating a transfer. So what I want to trick you to eventually do is click this I agree to pay you button. Here, when I click it, you can see the simple counter, right, is just being incremented some number of times. Yeah, I've gone ahead and clicked that button 10 times. But now, if I go back to the home page, if I go to the attacker site, now, under the covers, the attacker has put that victim page that we just saw in a hidden iframe, set the opacity to 0, but here, I'm going to trick you into clicking this button right here. Right here. Now, I'm actually clicking it some number of times, but you can see, just for the purposes of this demo, you can see, by clicking this Show Hidden Iframe, the underlying page. And I've actually incremented the counter an additional number of times by tricking you to click that particular button. Right? So that's clickjacking. Right? So how did this actually work in HTML? It's very simple. We've got the attacker iframe, and we've got the victim, right, in the iframe itself, and we've set the opacity to 0. Well, who cares? Who cares about clickjacking? Right? Well, what can you do with it? Clickjacking was actually discovered by Jeremiah Grossman and Robert R. Snake Hansen, and when they first released this research, they had a finding associated with it. And back in the day, Flash used to have this little pop-up box you see on the screen come up when it would want to enable your microphone and your camera. So what they did is they would, through clickjacking, trick you into clicking this OK button so that they could go ahead and spy on you. Pretty clever, right? Because under the covers, right, this page, this little thing would be hidden here, and the allow button, you'd actually be clicking on that. A more recent example is with Facebook. A while back, this post became somewhat popular on Facebook. The best passport application rejection in history. Now, well, why was this person's passport application rejected? Well, to find out, you actually just had to go ahead and click this text. Click to read why the guy was rejected. But instead of showing you why the guy was rejected, it sent you to some other malicious website that you didn't intend to visit, but that you got lured, that you got tricked into visiting. All right? So how does this code actually work? Well, the Facebook like code, right, in this case, because when you click that, it would actually like the page that the attacker wanted you to like. And this is a lot of code here, so let's look at this one step at a time. The first part here is setting the opacity to 0 to make the target page invisible using a number of different options here. The second part here is specifically iframing the victim. In this particular case, you're putting the Facebook like functionality into an iframe, right, tricking you, the victim, into clicking this like button. And in this case, the page that you were going to like is this credit report info, the best passport application in history. So thereby, the attacker is getting you to like this page. It becomes popular on Facebook. Other people are going to go ahead and click on it, driving more traffic to that particular site. Now, you might be thinking, I'm not going to click that best passport application rejection in history, right? I'm not going to go ahead and click the little button that happens to be perfectly overlaying the victim site, right? Well, there's a little trick that we could do. If I switch back to the VM, we've got this little like button demo, and you can see that that credit report info link, that was actually not that successful, relatively successful. Almost 16,000 people actually clicked that particular credit report info image. But here, if we go back and do a little demo of clickjacking, and I'm actually going to do that in Chrome here. So if I click this link, it's going to have a like button come up, right? But instead of tricking you to click this like button in this particular location, I can simply go ahead and wherever the cursor moves, move the button where I want you to click. Right? So it doesn't matter where I place the button. Using this little trick, I can have you click whatever button I want you to click. Right? By having the cursor, having the button follow the cursor itself. Now, I don't know, I think that's pretty awesome. Pretty clever. How does that actually work? Pretty clever. How does that actually work? Here is the code for it. And you can see all we're doing is basically taking the mouse move event, here represented by E, getting the X and Y coordinates for that, and then changing the coordinates here in the red for the like button itself. Right? Subtracting a little offset, but based on the X and Y coordinates of the mouse move event, changing the position of the like button itself. Right? Well, who cares? Right? Why would attackers do this? Why do people care about clickjacking? Well, you can send victims to evil sites with malware, so that then malware that would exploit vulnerabilities in unpatched software that you have running on your system, right? Unpatched operating systems, unpatched Adobe, Flash, Microsoft Office, and so on. Right? That malware will automatically be downloaded, exploit your machine, turn it into a bot, add it to the attacker's bot army. You can trick users into signing up for unwanted subscription services, like credit report services, or you could simply drive traffic to your website to increase ad revenue. And this is exactly what this company called AdSend Media allegedly did. Now, they're alleged to have made over $1 million per month using clickjacking. And this was shown to be true because Facebook and the state of Washington actually took the time to file a lawsuit against AdSend Media to force them to stop this practice. Now, they actually settled. The terms of the settlement weren't disclosed, but they were probably much less than the $1.2 million AdSend Media was actually making. So clickjacking can be a potentially lucrative business. So how do you actually prevent clickjacking from occurring in your applications? Well, in line with the theme here, you've got another HTTP header called X-frame options. Who has heard of X-frame options before? All right, maybe 10 folks. Now, you can use X-frame options to explicitly prevent your site from being framed to stop clickjacking from occurring. And you can use X-frame options to specifically say, well, I only want, here using the same origin option here, I only want stuff from the same origin to be able to be framed. Now, there's this other option here, allow from, where you can specify framing from these specified origins. But in my limited testing, it seems to only be supported by IE. Now, Firefox has another bug open here that basically says, hey, this was an unintentional oversight, and we're working to add this option into X-frame options as well. In your Java code, right, you simply add these things via headers, via the add header method, showing how you could do it with deny, same origin, or allow from. So let's go ahead and see how this actually works. Using X-frame options here, back in the VM, using Chrome, clicking the second link from the bottom here. Now, in this particular case, you guys remember this page. I could go ahead and click this Click Me button, and it would go ahead and increment the counter. But now, I'm sending down the X-frame options header, and when I try to show the hidden iframe, you can see that it's not there, because the browser is specifically denying this particular page from being framed. In Paros, if we look at what headers are sent down, you can see that we've got the X-frame options deny header sent down right here. Now, if I go ahead and switch the code, let me actually just go back to the home page. And now if I go ahead and try to do same origin, you can see that in this case, the same origin is attacker.com. I've simply just changed my host file. But the victim, right, the button that we want the person to click is on victim.com. So when I go ahead and do the click me, that still doesn't work. Show the hidden iframe here. But if I go ahead and do it from the same origin of victim.com and hit enter, now when I click me and show the hidden iframe, you can see that it's allowing that particular page to be framed. Right, so showing how we can allow framing or prevent clickjacking in specific situations using the X-frame options header. And if we go back and look in Paros here, you can see that all we have to do is change the value of the X-frame options header itself. So if I switch back to the slides, right, just some word of warning here. You might not want to use it for the entire site, because in some places it prevents legitimate framing in areas where you might want your site to be framed, like Google image search. For sensitive transactions, recommend using same origin value. Make sure you test it thoroughly. But of course, if the page should never be framed, just go ahead and use deny. Right? Now, what about browsers, older browsers that don't support the X-frame options header? Well, what became pretty popular is using some frame-busting code, which is basically some bit of JavaScript, that would be similar to this, right? Top not equal to self. Go ahead and set top location to self location. Anybody use this similar type of JavaScript in their applications? Just a handful of people, all right? Now, most modern browsers, right, all support this now, and so you might still see this code around, but it's important to realize that this protection is not foolproof. Right? There's some guys from Stanford that wrote a really nice paper a while back summarizing some of these issues. But here, you can see that if you've got the iframe security attribute enabled to restricted, well, of course, that actually disables JavaScript from running within the frame. Now, that's probably going to break most sites' functionality nowadays, but that will also prevent that frame-busting code from executing. Another way that an attacker could potentially bypass this frame-busting code is by sending a bunch of repeatedly sending 204 responses, so that when the frame-busting code changing the top dot location to self location tries to be executed, it's going to be blocked by the repeated 204s, because the on before unload handler will actually get canceled from all of those responses that you're sending. And finally, this relates to a comment that one of you guys had, is that the browsers now have these XSS filters built in. Right, using the XSS-Protection header. In this case, the code down at the bottom, the iframe, now it might be a little hard to read because it's URL encoded, but here we've got in this v parameter, right here, we've got if top not equal to self, exact same code we saw in the previous slide, change top.location to self.location. But here, right, it's possible that the XSS protection built into your browser would see this and say, hey, this is some reflected cross-site scripting attack potentially executing, and then block your legitimate frame-busting code from actually executing. All right, so just a couple things to keep in mind. Now, we've covered 3 of the most common web application vulnerabilities. Cross-site scripting, talked about how we can mitigate XSS using 3 different techniques. Using the HttpOnly attribute, using the XSS protection headers, and of course using content security policy. Talked about session hijacking, how you could mitigate that using the secure flag, as well as the strict transport security header. And finally, talked about clickjacking and how you can mitigate that using X-frame options. Right? So just to wrap up, right, we want to make sure that we use the headers in the appropriate ways. And I love content security policy, but make sure you plan on using content security policy because, well, like I said, it might take a little bit of work to remove inline scripts. Not much, right? A little bit of work to remove inline scripts, remove inline styles, and so on. Right? Now, at the top, I mentioned I do a little bit of work for the SANS Institute. On the left-hand side, we've got a bunch of free stuff that we have online. On the right-hand side is some info about our courses. The most important box on the right-hand side is the little one that says Secure Coding in Java, because that's the course that I wrote. That was supposed to be a joke. Right? But that's all I have. Thank you very much. Thank you. Any questions?
You mentioned the Firefox, Chrome, some other things, but you never mentioned Safari. Is that because Safari doesn't adhere to these headers?
No, so the comment is, we mentioned Firefox, Chrome, but maybe I didn't verbally explicitly mention Safari. I think it was on some of the slides, but yes, Safari does support these headers as well. It supports X-frame options. It's got support for content security policy because it uses WebKit under the covers. Yeah, and it supports the other ones as well. Yes?
The X-frame options, is it only for iframe or for the HTML frame set as well?
So the question is X-frame options only for iframes or for HTML frames as well? I'm not sure about that. I've only used it in conjunction with iframes. I haven't used regular frames in a long time. So yeah, I'm not sure. I'll have to check on that. I'll have to test that out. Yes?
What's your opinion with security applications made with Google Web Toolkits or similar?
So the comment is, what's my opinion with security related to apps that have been built using GWT, right? GWT, Google Web Toolkit. Honestly, unfortunately, I haven't had the opportunity to work with GWT deeply enough to sufficiently answer that question. So yeah, I'll have to take a pass on that one. Yes, back in the middle.
So for any non-trivial application, it seems you have to set a bunch of headers to prevent these security stuff from happening. But I think it's only because the browsers themselves are by default in the allow mode. So would it be better to work with the browser manufacturers to get into deny mode and use headers to allow?
So let me try to summarize. I think the question was, well, these headers, you have to actually explicitly set them. So would it be better or preferable to work more closely with the browser vendors, the browser manufacturers, to get some of these behaviors enabled by default? And yeah, there's kind of going forward, there's kind of 2 tracks. Is building more stuff into the browser, enabled by default. Also, on the frameworks that we might be using on the server side, we're starting to see some of this, having some of these options, sensible defaults, secure defaults, enabled out of the box. So definitely, and with the XSS-Protection header, right, we're exactly seeing that exact same thing, where that's enabled by default, and it's used to prevent some common reflected cross-site scripting vulnerabilities. So yeah, I think definitely that's the way to go. All right. Any other questions? If there isn't anything else, thank you all for... Oh, one more.
The
Right. So the question is, are there any frameworks that have filters to go ahead and set some of these headers automatically for you? OWASP, actually, the Open Web Application Security Project, which I mentioned, they have a number of different projects. Some of them have filters to go ahead and that have filters to go ahead and set some of these headers for you automatically. Yep. Yes.
Are there any vulnerabilities that you can't protect against? Are there any security?
The question, I think this is a loaded question, is are there any security vulnerabilities that you can't protect using these headers? And yes, absolutely. You will notice that when we talked about cross-site scripting, there are a few different flavors of XSS. But these headers are only protecting against reflected cross-site scripting. So if you have stored cross-site scripting where you, as a developer, are storing some evil data in your database, then that evil data gets displayed back to the user, you're still going to have persistent stored cross-site scripting as an issue. Right? That's very bad. But you can't stop that at the browser level because you don't know what code, what data is validly or invalidly coming from your app. So definitely there are other things that you have to watch out for. Yes?
Coming back to the blacklist question, is that information public? I mean, do the browser manufacturers publicize what checks they're doing so that we can find out if it's actually okay? Can I turn off my server-side XSS-Protection? I mean, do I use the browsers now or what?
Yeah, so the question is, with the X-XSS-Protection header in particular, for example, it's basically using a blacklist to look at the parameter and see if there's some evil data being used. Is that information made public? And yes, absolutely. Like Firefox is open source. We can actually go look and see what their actual implementation is. And fortunately, or unfortunately for us, well, there's security researchers that are testing these things all the time. There are attackers that are looking for weaknesses in these things all the time. When IE first implemented their reflected XSS filter in the browser itself, it had a couple little issues. And security researchers were quick to discover those, and that got a lot of press. And so just like with open source projects, that's good and bad. Good overall because there's people looking at this to see what the gaps might be. Anything else? All right, thank you guys for coming.